we have f of t is equal to e to the power of at. We are asked to find the Laplace transform of this function. Okay, now let's go. The Laplace transform of f of t, which is the Laplace transform of e raised to the power of at. Here, going by the definition of Laplace transform, we say that Laplace transform of f of t is the integral from 0 to infinity e raised to power minus st f of t dt. Okay, now the Laplace transform of e raised to power at is going to give us the integral from 0 to infinity e raised to power minus st. In place of f of t now, we'll replace with the function we have, e raised to power at dt. Now, going with the law of indices, since the base is the same, we add their powers. So that means we're going to have the integral from 0 to infinity e raised to power minus st plus at. We have the t. Okay, good. Looking at this power, we have minus st plus at. We can factor out the variable t. Okay, so when we do so, we're going to have the integral from 0 to infinity e raised to power minus s plus a in bracket t dt. Now, integrating properly, our variable is t. So the coefficient of t is what we're going to bring down. Okay, so here, integrating properly, we have e raised to the power minus s plus a in bracket t all over minus s plus a, and then our boundary 0 to infinity. Again, in this bracket, we can factor out 1 all over minus s plus a. Is that true? Yes, we can factor out 1 all over minus s plus a. So when we do so, we are going to have e raised to power minus s plus a in bracket t. Okay, and then we have a limit 0 to infinity. Let's plug in the upper limit minus the lower limit. Doing so, we're going to have 1 all over minus s plus a in bracket e raised to power minus s plus a, close the bracket. In place of t, we'll replace with infinity minus e raised to power minus s plus a, close the bracket. In place of t, we'll replace it with 0. So here, when you say minus s plus a multiplied by infinity, is going to give you 0. Okay, that is e raised to power minus s plus a multiplied by infinity is going to give us 0. Then we have minus e raised to power minus s plus a multiplied by 0 is going to give us 1. All right, good. Here we have 0 minus 1 is going to give us minus 1. The minus 1 times 1 all over minus s plus a is going to give us 1 all over s minus a. Okay, here we have minus 1 times 1 all over minus s plus a. So when you multiply this, it's going to give us 1 all over s minus a. All right, good. So here we see that the Laplace transform of f of t raised to power at is giving us 1 all over s minus a. All right, good. And then you see that this a can assume any number. For instance, let's assume that we have f of t is equal to e raised to power 4t. Okay, so if we say the Laplace transform of f of t, and then our f of t is e raised to power 4t, that means we say the Laplace transform of e raised to power 4t is going to give us 1 all over s minus 4. In place of a, we replace it with what? 4. So this is it. And also, if we have a function f of t is equal to e raised to power minus 3t, and then we are asked to find the Laplace transform of this function f of t, which is going to give us the Laplace transform of e raised to power minus 3t is going to be 1 all over s plus 3. Okay, so in place of a, we'll replace it with minus 3. So when we say minus 3, it's going to give us positive 3. So here we have 1 all over s plus 3. All right, good. Now let's go.